Yeah, you need something there?
Yeah, I'll take one.
Okay, so chapter 6. Chapter 5, we talked about object-oriented classes. We talked about inheritance and how you can kind of like overload your methods and so on. So we learned about those. Now, this chapter talks about abstract classes. So what's an abstract class? An abstract class is just like a class, but then the reason why is an abstract is because you cannot create objects out of an abstract class. Okay, so you cannot use that to instantiate objects. Usually, you use that as a base class for a more specific class or the standard class to extend and to inherit from, and then that subclass or the child class will do the instantiation of those objects. Okay, so abstract class is something like it's very very general in the sense that it can be applied, it can be shared by smaller or more specific classes. Like if you think about vehicle, right, or if you think about pets, so pet is a very generic class because under the pet class you can have subclasses like dogs, cats, and mouse and so on. Those are more generic. So all those other classes are have something in common, and you put anything in common in the abstract class, and then because you know the dogs and cats and mouse they make different types of noises, right? they do things differently. They're related in certain sense, but they're also different in the way that things they do. So something is not is similar, but then can be implemented differently. That you put that into an abstract class. Okay. So let's look at that in the code here, and then we'll see how it works. Usually it's easier if you just do some coding so we can see how that works. But abstract class, again, is a very general class that cannot be used to create objects. You cannot instantiate objects out of the abstract class. So in other words, you cannot use the word new something. Okay. Let's just do here. I will add a new file, and we'll call this maybe just um, chapter 6. Okay. So in the PHP code here, so I'm concerned about this part for now. So let's just say I have, we go with the pet class is fine. And to create an abstract class, you would, so abstract. Okay, so we have something like if I use the one in the book, the book uses the class called pet. So we have the class called pet, right? And to make this pet class into abstract class, you just put the keyword abstract in front. Okay, so now it's an abstract class. Now I cannot say pet. I cannot say dog is equal to new pet. Okay, because it's abstract, it cannot create a class out of that. If I have another class, a regular class called, maybe we should do like, yeah, it's fine, dog class, right? And then I could do that with a dog because it's not an abstract class. So I create an object called dog, which is fine. Okay. So you cannot use the abstract class to create an object, but you can use a subclass that extends the pet class to create objects indirectly out of that class. Okay? So you have to have a concrete class. This is called a concrete class because it contains everything here. Concrete is is not an abstract class. It's the opposite of abstract class. It's a full class. Then you can use a concrete class to instantiate objects, and that concrete class can can inherit a superclass, and that superclass can be an abstract class. Okay, so in here you could have
Is that to have encapsulation to or to that's not the right term. Why would you make
an abstract class.
Why would you want to abstract?
Okay, yeah, so good question. The reason is because, let's just say, you see in the example in the book, also last time what you do, so you have a function called, let's just talk, right? Now, if you put talk in here, you don't know what kind of pet talks like what. If I put a general, a default here, if I just say, this pet meows, well, it doesn't, because it could be a dog,
Yeah.
or it could be a mouse. So you don't know what that talk is, but each of these pet type can talk. So they have this talk function in common. So instead of implementing the function here, you let the subclass implement it by themselves. You just apply that class, you make that class function abstract. Okay? So now any subclass that inherits this pet class has to implement the talk class. So that's why you see the red line here. So in here I have to have the same function called talk, and then I have to implement the talk in here. Once I do that, then now this class is happy. So every extra function that you have up here is not implemented. You don't supply the implementation. Then other subclasses that extends that class has to implement that in here. If I have 100 of these classes, these functions here, I have to do them all of them down here in the concrete class. It's required. But then so now I can say the dog barks, and if you have a cat, right? And then we have a cat class that extends that pet class, and then we do the same thing. It says class must be declared abstract or implement the talk method. Unless this cat class is an abstract, then it doesn't need to implement the talk, because they're both abstract anyway. Okay, so if it's not an abstract class, then you have to implement the talk. If it's apply another abstract function here, called maybe should I say sleep, right? So you see that I have to implement that also. I have to implement both the sleep and the talk. Same thing with the dog here. So now in my code here, I have to provide that in here. Even though they don't sleep or talk, because the functions that you have to do it, even though it's empty, you have to supply it, even though it doesn't do anything there. Okay? It's just the rule. It applies to all languages, not just PHP. So Java will be the same as with C# and so on. So in here, I have to do the same thing here. I could just basically copy these in here to make them work. Okay? And also notice they don't have constructors, right? You can. I could have constructors in here. I could say, public pet, and then well, no, they don't. They can't have constructors because they can't create objects. So both of these classes, the cat and the dog, extends the pet class, and then because they talk differently, they sleep maybe differently. I don't know if it's the same or not, but just to show you that any class that is a subclass of the abstract class must implement any abstract functions. And in here you can have the field as well. So public, maybe like the name, because that's common to all of them. They might have a name. They might have like a type, right? So in here, I could, when I create this new dog, then the dog has access to the name and the type. So the name could be, you know, again, Milo. It's probably oldest, right? And then I have a cat class. And then the cat can have a name of Milo. Okay, so this name here is actually not from the concrete class, but from the abstract class. And because this is abstract class, it's the parent class, so you can call and use their variable names to. And it doesn't mean that abstract class have to have extra functions. You don't have to. You could have your regular function here as well. You can say, like, you know, run or something like that. And you could still do, like, you know, you could say this cat runs or something. Okay, so it would still be fine. So you have your regular function, it's fully implemented, and you can have your other functions down here. You don't have to, if you don't have these, okay, that's fine too. You don't have to have an abstract function. It's not required, but usually you do. Otherwise, what's the point of having an abstract class, right? Yeah. So usually you have abstract functions in here. Okay, so that's an abstract class. You can have an abstract class that would actually extend another abstract class. So up here I could have another abstract class called maybe animals or something, right? That could be an abstract class. And then this pet class could extend that animal class. Okay? So you can go up the tree this way. And the animal class, I could have, I don't know what's in here, but something that will be common to all of them here. Maybe like I can think of something that is common to all of them besides pet. Maybe like function maybe has fur or something, right? You can return that as true or false. You can make that implement here. So notice this is abstract function. It's abstract class inherited by another abstract class, so I don't have to implement that. But if you look down the tree here, you see that, oh, now I have another new method to implement has fur. Okay, it goes up the chain this way. So I have to implement that here as well. Has fur. And then same thing with the dog here. Okay? And you do that same thing for all the subclasses that inherit this abstract class. Okay, pretty straightforward, right? So, abstract is something that it's a class that is very, very generic in terms of, you know, the relationships between the subclasses. Okay, so let's talk about interface class. The interface is another type of class that is very similar to the abstract class, but it's very similar. Also, interface cannot be used to create objects. It can be extended from a subclass or a sub-abstract class, but you cannot use it to instantiate objects. So I could have interface, use a keyword interface instead of the abstract, and then you can just follow by the name. You don't put a class here, okay? So notice you have an abstract class name of the class. Interface is just This is like even more generic, just very, very broad. Um, maybe here you can have things like, I don't know, organisms, something like that, right? And it's a very, very broad class that would encapsulate all the other subclasses. So interface class does not allow you to have fields, cannot have properties. So I can't say public, name, like that. All it has is functions, and not just functions, but functions without implementations, like here. Okay, so I can have like public function, maybe like let's say get name, for example. Okay. So all you do is you just supply the function here, and you don't have to implement it. Actually, you cannot implement it. I can't go here and do something about this function called getName. Whereas I could do that inside the abstract, right? I could supply a full function implementation in here in the abstract class, but along with the abstract function here, but inside the interface, I cannot implement anything. All I do is just supply that function head, that function declaration, definition, and that's it. Maybe I put the abstract here, see. Yeah, so it's not an abstract class, right? So it's just a regular function, and then you don't implement anything like that. And if you want to implement it, then you need to implement through the subclasses. Okay. So now, this organism here, if I want to extend from the animal class to this interface, instead of the extends, this keyword extends only extends an abstract class or a normal concrete class. To do the interface, I need to implement the interface. Okay? So not extends, but implements, because as you can see, there's no implementation here. So I have to implement the interface class. And then if you go down the chain here, you see you run into the same issue, because it's all belong to the animal class. The animal implements the interface. Interface has a function called getName, right? And then down here, the cats and the dog class have to implement that function. So you have another one to implement, getName. Actually, what happened here? Class must be declare abstract to implement methods show breed. I have show breed in here. Okay, something's weird here. Why is it asking to show breed? Maybe it's in here. That's why I was delete that. Okay. Yeah, that was weird. Okay, so in the dog class, you could implement that. So the animal class implements the organism interface, and then so down here, if you notice, if I take this out, let's just say the animal doesn't implement that. If I take that out, okay, the pet can extend the animal class, but it can implement the organisms class. You can do this as well. So you can see it kind of like part of both, the animal and then the organism as well. Okay. So this is a subclass of the animal. It is also like a subclass of the organism, but the organism here is just an interface, And usually interface has a bunch of functions in here, just methods, very generic methods in here that you can implement in the code. Okay, so something very general in here. Again, you are not allowed to have any data fields, just a bunch of functions and pretty much function definitions. That's all you have. So if you think of interface here, if you think of, again, back to the example I mentioned earlier, that like this iPhone here, right? What type of interface do you have? Well, you have the power supply interface, you have the headphone interface, and you have, other interface you can plug into it. You don't know what's happening inside. It's in a black box, but it provides the interface to connect it to it. Okay, so interface is the same example as that. It's very, very, very broad and very generic in terms of its functionality. Okay, so the same idea here. So again, here's the pet, the dog, because it's part of the pet, and then the pet implements the organism. I need to implement this get name. So same rules apply. So function get name. And even though in the implementation, in the implements interface, I don't have the keyword abstract, I cannot put abstract here because that only goes into the abstract class. So it's just a regular function definition, and as soon as you implement that, or if you extend that class, then it asks you to implement it. Unless it's an abstract class, then it doesn't have to do that. Okay, because both of these type, the interface and the abstract classes, do not instantiate objects. Okay, they can't. So you kind of like do it indirectly by implementing the dog or the cat, and then you can go up the chain to access the data and then use the functions to do certain things. Okay, so you can do that indirectly. All right, so those are the three to actually abstract and interface. And then the toString here, it talks about the toString method here. Okay, this is a special method that's built into PHP, also in Java as well, and it allows you to kind of customize the output of the of your object. Okay, so for example, if I create a new object called A or some class here, if you echo the object A out, then you will see something really unusual, right? So for example, if I'd say here, I have, let's move this down here in the the page down here in the body. Okay, so I instantiate a dog and a cat, right? So if you want to print out the dog's name, then I would say echo dog and the name, right? That will print Otis. Let's see if it runs in the browser. So you see the dog's name here. Okay? And the same for the cat. But if I were to do like just dog without the name and so forth, okay, you see that it gives you this error because I'm trying to print an object of the class dog, and you can't really do that, right? You cannot convert to a string like the Otis is. It's an object. So to do that, you could convert it by using the underscore toString method, like it says in the book here. Okay, you can change this method. You can override this method to write something else that you want, right? So kind of like, not sure if it says, it doesn't say it. Okay, so let's see if we can implement that. So you can override this method called toString inside the dog class and the cat class. In here, I'll say function underscore toString. Okay, I'm going to return something back. Let's return a string. So I'll return like let's see, name. Does it take it? Let's return a string. Let's see. Okay. So I can override that string that says dog's name is that. And then when I run this statement, let's see if it changes that for us. Okay, it doesn't return a string value in the line 105. Let's see what's going on here. 105 echo dog. So dog is going here, and it overrides this function and return the string. Return the string. That is a string. Okay. For some reason, it doesn't like the string value.
You put the plus to concatenate it. Shouldn't it be?
Oh, the dot. Oh, that could be it. Let's see. Yeah, excellent. Good catch. We just finished with Java.
Yeah.
Yes. So you can see you can customize that output to return the dog's information by overriding this method here, the toString, and then you could just echo the object without doing the object dash name. And if you have more information about all this, I could do like type is or if it's breed, you could say, for example, poodle, right? And then instead of doing this, echo dog name, echo dog type, I could do all that inside the dog object one time. Okay, so I could just comment this out, and when I echo dog, I say when I echo dog, just give me everything about this dog. Okay, so you go into the dog class and you fix this message here, and you could say something like maybe like string is equal to that, dog's name is that, and then you have string dot equal, and then br. You could say like this name is a, and then here you put this. Oh, you can go on the same line, it's fine. And the parent and the double quotes this type. Okay, and then you just do return a string. Okay, so I could actually just could basically remove the whole thing and put it here. It's easier. Don't worry about the concatenation stuff. So it's going to print the dog's name is that, and then the type is that. So I let the function does all the printing for me, and all I have to do is just echo the dog out. Okay, and I should get Otis' name is Otis, and Otis is a poodle. Okay, so you override the function so that instead of echoing dog dash equal, the arrow name and type and so on, if you add all more data to this dog, you can access it directly by using that dog echo dog here. But of course, you can still do this. You can still echo each of those properties directly this way as well. So you only override this underscore toString if you echo the dog object, or if you echo the cat object. I could do the same thing for the cat. I would just again basically copy this function and then override that inside the cat function, which is in here, the cat class. And instead of dog, I say cat's name is that, and I get the same information. And if I were to also change the cat to the type to I don't know, Egyptian something. I don't know what that is. So, and then I can echo the dog and the cat object instead of their own properties. Those will be printed out to the browser. Okay, so it shortcuts that for you, and you customize it so it's unique in that sense that every time you echo the dog or the cat object, it always prints exactly like you see here. Okay, sometimes it's useful. Sometimes it's, I guess, not. Depends how you want to use it. But you can override this function. And the same rules for Java if you remember Java. Okay. So that's the mentioning of this string here in your constructor. So every constructor, I mean every class has this underscore to string to override if you want to override it. Okay, because you can create objects out of that class, and you can echo the object directly, and you can display the information within this string method here. All right, let's see what else. So that's just another example of how you can use abstract class for the shape, and then you have a more concrete class for triangle and square to calculate the area. This is another good example because shape has area, and area applies is calculated differently for each different object. So that's an abstract method, and then the concrete method class will have a more specific way of how you calculate areas of that shape. Okay, so interfaces, we talked about that already. Okay, so all you have is just the interface plus the name of the interface name, and then all your function definition will be set up here. So this one here has a parameter, whereas the one I had didn't have any. So you can have as many as you want. It's just that the one you have, then every subclasses have to implement all of them. Okay, it's required. What else do we have in here? For traits. Traits is something new in PHP 5, 5.4 to be exact. And traits is, remember I said that one class can only inherit one base class. You cannot do two, right? Unless one is an interface and one is a regular class. Like here, we see that the pet class inherits the animal and also kind of like inherit the organism, but this is an implementation of the class. So if you want the cat class to extend the pet in another class, well, you can't, right? You can't just say, oh, I want to extend cat and have another class here called something like maybe I don't know, full leg or something, right? Full leg class. You cannot extend both of them here. I can just say full leg. You can't do that, right? So the trait allows you to do something like this in a way. So instead of saying that, I can change this to trait. Okay, like you see here in the book here, the trait. And then you can, inside the trait, you can have your attributes and other things in here that you can use or share inside other classes. So here could be like, for example, I can have a function called how do I say, maybe like stand. Okay, and then this function can do something about standing. And I want to use this stand class in the cat and in the dog, but they don't inherit this class. So we use that as a trait. So inside here, I just say use the trait called full leg. Okay, if I put that in here, So now it's almost like extending the another class called full leg, and then in here I can now access this stand. So it's a part of this class now. So the cat, you see that if I do cat down here, if I say cat, you see the stand is part of that, right? I can call stand from here. But the dog I can't, because dog is not part of the see, dog is not part of that. That dog doesn't have that trait. So that's another way of how you can actually kind of like have a class extend more than one class, sort of. So you can treat this like a regular class. And if you have like another one, for example, maybe put 2 here. Wondering if I could just do that work and use. I don't think I could just put here, right? Yeah, so I can have 2 now, and 3. You can have multiple traits to apply to that class. And this is useful for things like in your debugger. When you write your code, you want to debug your code, and you want to output the data to the screen so you know what it is. So instead of writing every class for that class or functions in here, they share the same function to output some data. You put that into a trait, and you use that inside your code so that every class can access this information here, this function, without having to create their own unique functions in here. So it's really useful for that situation. And I guess there are traits so that you don't have, you cannot create objects out of that. It's just a way to provide some additional data and a function to use in the classes. Okay, so that's trait. I think PHP is probably one of the few, if not the only languages that has traits. Java doesn't have it. Okay, so I don't think it does. So that's trait. Let's see, what else does it have here? We have hinting. We're not going to do that. Just type hinting. And then we have something called, I think, namespaces. Yeah, namespaces here. Namespaces here is just a way for you to, categorize or organize your files into different folders. That's all. Because sometimes you might have the same file name, right? And then you can't have that in the code. I mean, in your directory. So you can put that into a separate directory, and then you use the namespace to kind of organize your file in a separate directory. So you use the namespace in there. So for example, I have if I have two similar files, then instead of having that in the same directory, like the home directory, like I have another one called chapter 6 in here. Instead of doing this, I will put that into their own separate folders. And then I'll just use that folder into the namespace. So the namespace will give you that option. So this is like similar to Java in what's called a package. Okay, you can use a package instead of package. You have the same. In the package, you have the same file name, same classes, and so forth. So if you want to call a class or another object inside a different package, then you would do that by specifying the namespace called myutilities inside a file called user management, and then here you have your classes and you can access this information. Okay, so and then you can instantiate your objects based on that location. So it's just another way of how you organize your data, your files, if you have the same file names. You might run into those situations, but I think that's kind of rare, but it's possible that you will run into that situation. If you do, then you want to use namespaces. All right, I think that is the last piece in this chapter. Okay, and then for the assignment, I think it's pretty simple. So the homework assignment, basically ask you to create a class called vehicle, and you make that vehicle class an abstract class. Okay, and then you're going to have three fields: speed, engine size, and class. The class could be like type. Okay, what class is this vehicle or this object is, and you need to create a setters and getters for those fields. So you can change the state or the values of these fields. You can also get them, and then you're going to create about 4 abstract methods called start, stop, break, and show information here. And then you create 3 subclasses: car, plane, boat. And then so you're going to initialize each of these with the field, the speed, engine size, and the class, and so forth. And then these going to extend the vehicle class, which is an abstract class, and it's going to ask you very likely to implement these methods here. So implement those methods, how you would start the car, how you start playing on a boat, and so on, and then just show those information to the screen by using this show info method here. Okay, so it's pretty straightforward. If you want to go beyond this, by all means, it's just only to your benefit if you do that. But that's all required to do that, and I hope that you, it's not really hard. It's just a lot of different techniques. How do you separate classes to abstract, and how do you know when to use abstract and not a regular concrete class? So anything that is very general in terms of the hierarchy, and if that class can be, or the methods or the properties can be shared by other subclasses, then make that into an abstract class. Okay, and so you can use that class. And if you don't have to make it into abstract, it could be a base class, which is another concrete class. Okay, and then the interface. And again, usually your applications, if it's really small, you don't need to do that. The abstract, the interface are usually for the really large applications. You have a really huge library. You want to share that to other users, and they can use it. So they will, you will provide all the implementations and the subclasses. Then you would create a abstract or interface for them to do that. But I hope that this is just to give you a good example of how to do that yourself, and also do the exercise in the book. The examples with the I think the shapes that also kind of help you out. But it's really easy. If you run into any issues, just let me know. But I think your assignments so far, it looks fantastic. You did a pretty good job on those. So at least tell me you know what you're doing, and so that's a good thing. Okay, and for the Java classes, you got like a couple of steps ahead of the Java class, because we haven't talked about these yet until chapter 10. So PHP goes really fast into object-oriented. Okay, so are there any other questions that you have, or anything you want me to go over in any previous assignments? I think you guys all caught up with chapter unit 5. You have, right? Yeah. Okay.
I did figure out I got your response to the PHP myadmin.
Oh, okay.
The URL.
Mm-hmm.